The initial basic feasible solution of a transportation problem that was obtained using Forge's approximation method is shown below. In this tutorial, I'm going to use the stepping stone method to find the optimal solution. So using that initial basic feasible solution, we will start by looking at the unoccupied cells. For all the unoccupied cells, we would have to calculate the change and then obtain the net change. So I'll start by looking at the cell there, this one here that I've highlighted in green, cell F1A. And we want to calculate the net change for this particular cell. So what we do is we trace a closed path to this highlighted unoccupied cell via cells that are currently occupied. The cells that are currently occupied are the ones that have 40, 80, 10, 30, 30, and the 50 there. So in this case, if we add here on this unoccupied cell, on this row, it will become unbalanced there, the 120, because we would have added an additional one. So we would need to subtract in this row the additional one that we've added there, and we would have to subtract it from a cell that is occupied. So the cell that is occupied in that row is the one that has an 8 there. So I'll put it there to the one which has an 80, so we'll subtract there. Note that I did not subtract on the one that has a 40. Because for the one that has a 40, it will be difficult to come back to that cell which is unoccupied. That is why I left it. But now when we are looking at column D, if we subtract there, then it becomes unbalanced because we have subtracted. So we would need to add, and would add to where we have the occupied cells, because we said when you are tracing the path, we use occupied cells. So I'll add on this cell here. So I'll put a plus there. But when you add a plus there, that means that row now, the one with F2 is now unbalanced. We would need to subtract. So we'd subtract on the one where we have the 10 there. And we see that we now have finished our path, which now goes back to the unoccupied cell. And all the things now will be balanced. So what we now need to do is to calculate the net change by adding together the unit cost figures found in each cell containing the plus, and then subtracting the unit costs in each cell containing a negative sign. So the costs on where we have the positive, so it will be 20 there, and we would have a 20 minus 4, then plus 7, then minus 24. So our change will be 20 minus 4 plus 7 minus 24, which will give us a net change of a minus 1. We now move on to the next cell and repeat the same process. The next unoccupied cell is this one here, cell F1C. So that's the cell that we are now looking at, and we go on again and trace a closed path to this highlighted cell via cells that are currently occupied. So we start from this cell. If I add here, for us to remain balanced, I would have to go here, then subtract. To balance the column, I would have to go here and then add. Because when you add subtract in a column, it will be a 0, so that's why I'm saying it will be balanced. And then to balance it there for the row, we go here and then I subtract. And then when you go back here, then it's all balanced, positive, negative, positive, negative. So it will give us a net there of a 0. We then go on and calculate the net change by adding together the unit cost figures found in each cell with a positive sign, then subtracting the unit costs in each cell containing the negative sign. So in this case, we would have a 17 minus 4 plus 7 minus 9. We are looking at the cost there. So the change is 17 minus 4 plus 7 minus 9, which will give us a net change of 11. We now move on to the next unoccupied cell. We are now here. So looking at this unoccupied cell, we go on and trace a closed path to the highlighted cell there using cells that are currently occupied. So if I add here to balance that row, I would have to go on and subtract here where we have the 30 there. Then to balance this column on the D, if we subtract, we will need to go on and add here where we have the 8 there. And then in this case, this row where we have F1 will be unbalanced. So we need to subtract, and we'll go on and subtract here. And then we go back to our unoccupied cell. So we now have a closed path. And then we go on and calculate the net change by adding together the unit cost figures found in each cell with a positive sign, and then subtracting the unit costs in each cell containing a negative sign. So in this case, our change there will be the 37 minus 7 plus 4 minus 22, and that will give us a net change of 12. We are done for this cell. We now move on to the next unoccupied cell. We are now at this cell here, cell F3B. So we trace a closed path to the highlighted unoccupied cell via cells that are currently occupied. So if I add here, we would have to subtract somewhere so that this column is balanced. So I'll go to where we have the 40 there. And then we subtract there. And then we would have to add. So I'll go on and add here. And then I will go on and subtract in that column there, where you have the 30 there. And then when we subtract here, that means this row is no longer balanced. We need to add somewhere in this row. So I'll go to this part here and I'll add. But when we add in this row, which is the column A, the column A becomes unbalanced. So we need to subtract. So we'd have to subtract on here where we have the 50 there, subtract, and then we complete our closed path here. So now that we have completed our closed path, we now go on and calculate the net change by adding together the unit cost figures found in each cell containing the positive sign, then subtracting the unit cost in each cell containing the negative sign. So our change there will be 37 minus 22 plus 4 minus 7 plus 24 minus 32. And that will give us a 4. We are now done with this cell. We move on to the next unoccupied cell. Is this one here, cell F3C. For the cell F3C, we go on and trace a closed path to this highlighted unoccupied cell using the cells that are currently occupied. So if I add here, I'll go on and subtract here where we have 30, and then go on and add here where we have 10, and then go on and subtract here where we have 50, then go back to the unoccupied cell. So we have now completed our closed path. We then go on and calculate the net change by adding together the unit cost figures found in each cell containing the positive sign, then subtracting the unit cost in each cell containing a negative sign. So the change there will be 20 minus 9 plus 24 minus 32, and that will give us a net change of 3. We now move on to the next unoccupied cell. Is this cell here, and is cell F3D. So for this cell, we trace a closed path to the highlighted cell via the cells that are currently occupied. So I'll add here and then look for an occupied cell, and I'll go on and subtract here, and then look for another occupied cell. I'll go on and add here, and then go on and subtract here, and then we now have our closed path there. And go on and calculate the net changes by adding together the unit cost figures found in each cell containing the positive sign, then subtracting the unit costs in each cell containing a negative sign. So our change there will be 15 minus 7 plus 24 minus 32. That will give us a net change of a 0. So we are now done looking at all the unoccupied cells. And then we go on and check if the solution is optimal. A solution is optimal if all the changes are greater than or equal to 0. So if all the changes are greater than or equal to 0, we would have obtained the optimal solution. But in this case, we see that there is a minus 1 there on the net change for F1A. So we haven't found the optimal solution yet. So in this case, we have not yet found the optimal solution because we are having a net change that is less than 0, the minus 1 here, this one. So what we need to do is we need to go on and see how much we can allocate in that cell F1A. Because what you do is we check the cell with the most negative net change. But in this case, we are just having one cell with a negative net change. So that's the only cell that we can allocate. But if you have many cells that have negative changes, then you take the one which is the most negative. So in this case, we try to see how much we can allocate in that cell F1A, the one with the negative net change. And to see how much we can allocate, we should go back to the closed path that we used when we were calculating these net changes. If you still recall, the closed path that we had there is those plus minus there. That was the closed path. So looking at this closed path to see how much we can allocate, we look at the cells where we had the negatives. So for the cells that have the negatives, we have an allocation of 10 and 80. So what we do is we take that minimum of the 10 and 80, then we allocate it to cell F1A. So in this case, we are looking at the minimum there. We are saying is a 10. Both the minimum of 10 and 80 gives us a 10. So in this case, we would have to allocate that 10. And we allocate that 10 to all the cells that have the positive signs and subtract it from cells that have negative signs. So on all the cells there where we have the negatives, we are going to subtract a 10. On the cells where we have the positives, we are going to add the 10. So what you have to do is you would have to draw another transportation table with the unit costs there, then go on and make the allocation as I have said. So where we have the positive there, we are going to put a 10. And where we have that positive there, we are having a 30. So if we add a 10, it will become a 40. So I replace that with a 40. We now look at the cells where we have the negatives. On the cells where we have negatives, we will subtract a 10. So when we subtract a 10 on the cell that has the 10 there, the cell F2A, it will become a 0. So we get rid of this 10. Then on the cell that has the other negative, the 80 there, we will need to subtract. So it would have an 80 minus 10 and it will give us a 70. Then the other allocations remain as they were previously. So this is the new table that we would have. And for this new transportation table, we go back again to calculating the net changes. So when you are calculating the net changes, we look at the unoccupied cells, and we will start by looking at this first unoccupied cell here, cell F1C. So for this cell, we traced a closed path to this cell via cells that are currently occupied. So I'll add here and then move on to this occupied cell. Then I subtract. Then move on to this occupied cell and then I add. Move on to this occupied cell, we subtract. Then back to that unoccupied cell. So we've completed our closed path. Then we go on and calculate our net changes by adding the costs on the cells with the positives subtracting the unit costs in the cells with the negative sign. So in this case, our change will be 17 minus 4 plus 7 minus 9, which will give us the net change of an 11. I now move on to the next unoccupied cell, on this cell here, cell F2A. Trace a closed path to this highlighted cell via the cells that are currently occupied. Then I'll put a positive here because that's where we are starting on the unoccupied cell. We'll move on to this occupied cell. We put a negative. Move on to this occupied cell, put a positive. Move on to this occupied cell. We subtract, then back to our original cell. So we have our closed path. Then we go on and calculate our net changes. So we are adding where we have the positive signs, then subtracting the unit costs where we have the negative signs. So our change there will be 24 minus 20 plus 4 minus 7. And the net change there will give us a 1. I now move on to the next unoccupied cell. It's this cell here. And for this cell, we trace a closed path to the highlighted cell, the cell F2B, using cells that are currently occupied. So we add here, that's where we are starting. Move to an occupied cell, we subtract here. Move to another occupied cell, we add here. Move to another occupied cell, and then we subtract here, then back to the unoccupied cell. And then we go on and calculate the net change by using the cells with the positive signs. We add the costs. Then on cells with negative signs, we subtract the unit cost. So it will be 37 minus 22 plus 4 minus 7. That will give us a net change of a 12. Move on to the next unoccupied cell. Is now at this cell here, cell F3B. We trace a closed path to this cell via cells that are currently occupied. So if I add here, I'll now move on to an occupied cell here, and I'll subtract. Move on to an occupied cell here, add, move to an occupied cell, subtract, and then back to our unoccupied cell. Then we go on and calculate the net change. Where we have the positives, we'll be adding the unit costs, and where we have the negatives, we'll be subtracting the unit costs. So our change there will be 37 minus 22 plus 20 minus 32, and that will give us a net change of a 3. We are done with this cell. We'll move on to the next cell there, cell F3C. For cell F3C, we trace a closed path to this unoccupied cell via cells that are currently occupied. So I'll start by adding here, then look for an occupied cell, and then go on and subtract. Move to another occupied cell, and go on and add. Move to another occupied cell, move to an occupied cell, and go on and add here. And then we move to another occupied cell, and then we go on and subtract, and then back to the unoccupied cell. So we now have our closed path. Then we calculate our net change. For our net change, where we have the positives there, we'll be adding the unit costs, and where we have the negatives, we'll be subtracting the unit costs. Our net change will be 20 minus 9 plus 7 minus 4 plus 20 minus 32, and that will give us a net change of 2. We now move on to the next unoccupied cell, is this one here. So we trace a closed path to this cell F3D via cells that are currently occupied. So I'll go on and add here, then move on to an occupied cell, to this one here. I'll go on and subtract, then move on to another occupied cell here, and go on and add, then move on to another occupied cell here, go on and subtract, and then back to the unoccupied cell. So we now have our closed path there. We go on and calculate the net change. For the net change, we are looking at where we have the positives, we'll be adding those unit costs, and where we have the negative signs, we'll be subtracting those unit costs. So our change will be 15 minus 4 plus 20 minus 32, which gives us a minus 1. So when we have that minus 1 there, we need to check if the solution is optimal. A solution is optimal if all the net changes are greater than or equal to 0. But in this case, we are having for the net change for F3D, there is a minus 1. It's less than 0. So we have not yet reached an optimal solution. So what we need to do is we need to allocate as much as possible to the cell with the most negative net change. In this case, it's cell F3D is the one that is the negative net change. So we need to allocate there just because the solution is not yet optimal. So what we are saying is we are looking at the cell F3D there. It is a minus 1 as the net change. And that's why we are saying the solution is not optimal. And to see how much we can allocate to that cell F3D, the one with the negative net change, what we do is we look at cells where we had negative signs when we traced the closed path. So we were having the negatives on the 50 there and the 70. So we take the minimum of the 50 and the 70. So that is that is the amount that we have to allocate in F3D. So that minimum we are saying is a 50. So we have to add the 50 to cells where we have the positives, then subtract the 50 from cells that had the minus there. So you would have to draw another table, and in that table you'll be now consulting this table here, then add to cells with the positive, you add 50, cells with the negative, you subtract a 50. So draw another transportation table, then do those allocations. So what we need to do there, where we have the 50, we are saying we are subtracting, so this 50 goes. And where we had the 10 there, we are adding a 50, so it will become a 60. Then where we had the 70, we are subtracting the 50 because it had a negative there. 70 minus 50, it gives us a 20. And then we are done with the allocation. So the new table will be looking like this. Here's allocation 60, 40, 20, 30, 40, 50. Just because the other allocations remain as they are. The only changes were where we had the positive, negative on the closed path. Now looking at this new transportation table, we now have to calculate the net changes again for all the unoccupied cells. So I'll start with this one, cell F1C. For the cell F1C, we trace a closed path via cells that are currently occupied, starting at this cell. So I'll put a positive, move to an occupied cell, put a negative, move to another occupied cell, put a positive, move to another occupied cell, put a negative, then back to the unoccupied cell. We now go on and calculate the net change by looking at where we had the positives. We'll be adding those unit costs, and where we had the negatives, we'll be subtracting the unit costs there. So the change there will be 17 minus 4 plus 7 minus 9, and that will give us an 11. We move on to the next unoccupied cell, which is cell F2A. So for this cell F2A, we trace a closed path via cells that are currently occupied. So starting at this cell, I'll add here, then go on to an occupied cell, and then subtract, move to another occupied cell, then we add, move to another occupied cell, we subtract, and then back to the unoccupied cell. We can now go on and calculate the net change by adding the unit costs where we have the positives, then subtracting the unit costs where we have the negative signs. So our change there will be 24 minus 20 plus 4 minus 7, and that will give us a net change of 1. We now move on to the next unoccupied cell, this cell here, cell F2B. We trace a closed path via cells that are currently occupied. So starting in this cell, I'll put a positive, and then move on to an occupied cell, put a negative, and then move to another occupied cell, put a positive, move to another occupied cell, put a negative, and then back to the unoccupied cell where we started. We then go on and calculate the net change. Where we have the positives, we add the unit costs. Where we have the negatives, we subtract those unit costs. So the change there will be 37 minus 22 plus 4 minus 7, which will give us a net change of 12. We move on to the next unoccupied cell, and this cell here, cell F3A. We trace a closed path via cells that are currently occupied, starting at this cell that I've highlighted. So I put a positive there, then move to an occupied cell, subtract, move to another occupied cell, which is positive there, move to another occupied cell, then you subtract, and then back to the unoccupied cell. We then go on and calculate the net change. For the cells that have the positive sign, we add the unit costs. For the cells that have the negative sign, we subtract the unit costs. So it will be 32 minus 20 plus 4 minus 15, which gives us a 1. Then move to the next unoccupied cell, this cell here, cell F3B. For cell F3B, we go on and trace a closed path using cells that are currently unoccupied. So we start at this unoccupied cell. I'll put a positive, and then go to an occupied cell, put a negative, then go to an occupied cell here, put a positive, go here to an occupied cell, put a negative, then back to the unoccupied cell. We then go on and calculate the net change. We look at where we have the positive. Where we have the positives, we add the unit costs. Where we have the negatives, we subtract those unit costs. So our change there will be 37 minus 22 plus 4 minus 15, which will give us a net change of 4. We now go on to the next unoccupied cell, this cell here, cell F3C. Trace a closed path to this cell via cells that are currently occupied. So starting in this cell, we put a positive, then move to an occupied cell. I'll move here, then put a negative there. Move to another occupied cell, then we'll put a positive. Then move to another occupied cell, then put a negative. Then back to the unoccupied cell, then we complete our closed path. We then go on and calculate the net change. Where we have the positive signs, we add those unit costs, and where we have the negative signs, we subtract the unit costs. And therefore, our change there will be 20 minus 9 plus 7 minus 15, and that will give us a net change of 3. We now need to check if the solution is optimal. A solution is optimal if all the net changes are greater than or equal to 0. In this case, we are having all the net changes are greater than or equal to 0, so we have reached the optimal solution. So when you have reached the optimal solution, what is left is for us just to make an interpretation of that transportation table. So I'll write down another table where we have the destination, the allocation, and the cost. What we are saying is from source F1 to destination A, we are allocating 60 units. 60 units at a unit cost of 20. So the cost will be 60 times 20, which gives us 1,200. From F1 to B, we are allocating 40 units. 40 units at a unit cost of 22. So the cost there will be 40 times 22, which gives us 880. From F1 to D, we are allocating 20 units. 20 units at a unit cost of 4. The cost there will be 20 times 4, which gives us an 80. From F2 to C, we are allocating 30 units. 30 units at a unit cost of 9. The cost there will be 30 times 9, which gives us a 270. From F2 to D, we are allocating 40 units. 40 units at a unit cost of 7. The cost there will be 40 times 7, which gives us 280. From F3 to D, we are allocating 50 units. 50 units at a unit cost of 15, and the cost there will be 50 times 15, which gives us 750. And then I'll go on and add those costs. The cost there will be 3,460. So that's the optimal solution, which we obtained using the stepping stone method.